Welcome to the DIY Honda Garage channel. The DTC P0713 indicates an issue with the automatic transmission fluid ATF temperature sensor, specifically an open circuit condition. This sensor plays a crucial role as it monitors the temperature of the transmission fluid, providing essential data to the powertrain control module, PCM, for optimal operation. The ATF temperature sensor is typically located near the transmission, ensuring it accurately measures fluid levels and conditions. If it detects a temperature outside predetermined thresholds, the sensor relays this to the PCM, which adjusts transmission performance accordingly. An open circuit means there is an electrical issue, potentially stemming from damaged wires or poor connections, rather than a mechanical problem within the transmission itself. Thus, it's essential to troubleshoot and verify the electrical integrity of this sensor first, before assuming the transmission itself is malfunctioning. Preventive maintenance is key in avoiding future issues related to DTC P0713. Regular inspections of the wiring harness related to the ATF temperature sensor can help identify early signs of wear, damage, or corrosion. Keeping connectors clean and ensuring a secure fit will promote good electrical connections and minimize the risk of intermittent failures. Additionally, regularly updating the PCM software can prevent miscommunications between the sensor and the module, ensuring that all components remain compatible and efficient. Using high-quality parts for replacements will also support the overall health of the vehicle's transmission system. By instituting a routine maintenance schedule, vehicle owners can enhance the reliability of their Honda Accord and extend the life of its transmission. In conclusion, diagnosing and repairing DTC P0713 involves a straightforward yet thorough process centered around the ATF temperature sensor. The critical role of this sensor in managing transmission fluid temperature illustrates its importance for optimal performance and efficiency. Each troubleshooting step, from verifying vehicle status through electrical testing, leads technicians toward identifying the root cause of the issue, whether it be a faulty sensor or wiring problem. Emphasis on maintaining electrical integrity is paramount. Thus, addressing connections, wires, and PCM updates can lead to successful resolution and prevention of future faults. Overall, a methodical troubleshooting approach equips technicians with the necessary framework to effectively resolve similar DTCs in the Honda Accord, promoting a reliable driving experience. The DTC P0713 can appear in either confirmed or pending status. Confirmed DTCs indicate the error condition is currently active, while pending DTCs suggest that the error has occurred but may not be active at the moment. Before undertaking any troubleshooting steps, it's crucial to record freeze-frame data. This data provides valuable insight into the vehicle's condition at the time the error was triggered. Notably, this DTC strictly relates to an electrical circuit problem surrounding the ATF temperature sensor, ruling out issues stemming from mechanical failures within the transmission itself. This distinction is vital for directing your troubleshooting efforts toward electrical connections and sensors, rather than transmission components. Several potential causes contribute to the triggering of DTC P0713. First, a damaged wiring harness may interrupt the electrical signal from the ATF temperature sensor to the PCM. Any physical damage or abrasions are critical red flags. Second, a loose or corroded connector at either the sensor or PCM could lead to intermittent connectivity or poor signal transmission, making it essential to inspect these connections meticulously. Third, the ATF temperature sensor itself may be malfunctioning due to internal failure, thus producing erroneous readings. Lastly, issues with the PCM, such as outdated software or component failure, can incorrectly process signals, so verifying the integrity and software version of the PCM is necessary during troubleshooting. These possibilities highlight significant avenues to explore in resolving the DTC. Drivers may notice various symptoms associated with DTC P0713. First, the warning light on the dashboard will likely illuminate, alerting the driver to an issue that needs attention. This light commonly signifies a range of problems, but combined with this specific DTC, it's tied to the ATF temperature sensor. Additionally, the vehicle may experience transmission performance issues, such as slipping or harsh engagement, as the PCM may be unable to optimize shifting based on inaccurate fluid temperature readings. Erratic shifting behavior can also manifest, leading to a frustrating driving experience. Lastly, increased fuel consumption may occur as the transmission fails to operate efficiently. Recognizing these symptoms early can prevent further damage to the vehicle and enhance overall driving safety. The initial step in troubleshooting DTC P0713 involves verifying the vehicle's current status. Begin by pressing the engine start-stop button to switch the vehicle to on mode without starting the engine. Next, utilize the Honda Diagnostic System, HDS, to check the parameters related to the ATF temperature sensor. Specifically, focus on the voltage reading from the sensor. It should be above a threshold of 4.93 volts. If the reading meets or exceeds this value, it confirms that the system is exhibiting the failure condition, and you should proceed to the next step. However, if the reading does not meet the specified threshold, it suggests an intermittent failure, which necessitates checking for poor connections or loose terminals between the ATF temperature sensor and the PCM. Accurate assessment at this stage is crucial for effective troubleshooting. In the second troubleshooting step, the goal is to identify the potential failure area concerning the ATF temperature sensor circuit. Begin by powering off the vehicle using the engine start-stop button, and then disconnect the ATF temperature sensor 2P connector. Subsequently, create a temporary circuit by connecting terminals A and B with a jumper wire, where terminal A corresponds to the ATF temperature sensor's number 1 terminal, GRN, and terminal B is grounded to the vehicle's body. Once the jumper wire is in place, power the vehicle back to on mode. With the HDS, once again, check the voltage from the ATF temperature sensor. If the measured voltage drops below 0.07 volts, the following step will confirm whether the issue lies with the sensor or elsewhere in the circuit. The readings at this stage will use voltage levels to guide the technician on what corrective action to take next. The third step involves a detailed analysis of the ATF temperature sensor itself. Start by ensuring the vehicle is off, and then remove the previously placed jumper wire to restore the normal circuit configuration. Next, connect a new jumper wire between terminals A and B, specifically linking the ATF temperature sensor 2P connector number 1, green, to number 2, gray, terminal. Once the jumper is secure, again switch the vehicle to on mode. Utilize the HDS to check the voltage readings from the sensor. If the voltage remains below the 0.07 volts threshold, it confirms that the ATF temperature sensor has failed and needs replacement. Alternatively, if the readings are acceptable, the sensor is operational, and the technician must then focus on finding an open circuit in the SG2 wire connecting the ATF temperature sensor to the PCM. This step is crucial in isolating the exact cause of the issue. For the final step of troubleshooting, the focus is on verifying the integrity of the wiring specifically related to the ATF temperature sensor. Begin by ensuring the vehicle is powered off and the jumper wire is removed. Disconnect the ATF temperature sensor 2P connector and proceed to utilize the HDS to jump the SCS Service Check System line. Following this, disconnect the PCM connector B, which contains 51 pins. After these connections are secure, perform a continuity test between the designated test points, the ATF temperature sensor 2P connector, number 1, green, and PCM connector B, number 39, green. If continuity exists, it signifies that the TATF wire is intact. In this case, updating the PCM software or substituting it with a known good unit will be necessary before concluding the repair process. In contrast, if continuity is absent, the technician must address an open circuit in the TATF wire between the sensor and PCM. Once all necessary repairs and replacements have been made concerning DTC P0713, a thorough verification process is essential to ensure the issue has been rectified. Begin this step by reconnecting all previously disconnected connectors, ensuring a secure connection to prevent future faults. Next, exit the SCS mode with the HDS and power the vehicle to on mode. Clear the DTC using the HDS to reset the vehicle's diagnostic system. Following the clearance, start the engine with the shift lever in the park position and allow the vehicle to idle for at least 20 seconds. Finally, monitor the onboard diagnostics OBD status for DTC P0713 in the HDS DTCs menu. A passed status indicates successful troubleshooting and repair, while failed or not completed statuses warrant further investigation into connections and other DTCs that may have arisen. Please like and subscribe to the channel. See you next time.